Have you ever wondered what it would be like to witness the birth of a new ocean? Right beneath our feet, one of Earth's most dramatic geological events is unfolding at an unexpectedly rapid pace. The African continent is literally tearing itself apart, and scientists have discovered this process is happening much faster than previously thought. The Great African Split. The East African Rift System stretches over 3,000 kilometers from Ethiopia southward through Kenya, Tanzania, and Mozambique. This massive geological feature represents something extraordinary: the boundaries where the African continent is slowly splitting into two separate landmasses. The Somali Plate to the east is gradually pulling away from the much larger Nubian Plate that makes up most of Africa. Recent research has revealed that parts of this rift system are separating at rates approaching 7 millimeters per year, significantly faster than the 4 to 5 millimeters previously estimated. While that might not sound dramatic, in geological terms, it's remarkably quick. This acceleration suggests that the forces driving this continental breakup are more powerful and dynamic than scientists initially calculated. The Afar Triangle, Ground Zero. The epicenter of this continental division lies in the Afar Triangle in Ethiopia, where three tectonic plates converge. This region has become ground zero for studying continental breakup, as it provides a rare opportunity to observe active rifting processes. In 2005, a series of earthquakes in Ethiopia created a 60-kilometer-long crack in the ground, practically overnight. Over just a few weeks, this fissure widened to 8 meters in some places, with the ground dropping by as much as 4 meters. This dramatic event showed that continental breakup doesn't necessarily happen gradually; it can occur in sudden, dramatic episodes. Spectacular landscapes and volcanic activity. The physical manifestations of this continental divorce are spectacular. The Great Rift Valley features some of Africa's most iconic landscapes: deep valleys with steep escarpments, active volcanoes, hot springs, and lakes formed in the depressions created by the rifting process. Mount Kilimanjaro, Mount Kenya, and the volcanoes of Ethiopia's Danakil Depression all owe their existence to this rifting process. As the continental crust stretches and thins, magma from the mantle finds pathways to the surface, creating volcanic activity. The Danakil Depression is particularly fascinating, lying below sea level. It's one of the hottest places on Earth, featuring salt flats, acidic hot springs, and colorful mineral deposits that make it appear almost alien. The birth of a new ocean. Perhaps most exciting is the final outcome of this rifting process: the birth of a new ocean. As the continental crust continues to thin and separate, eventually seawater will flood into the lowlands, creating first a narrow sea similar to the Red Sea, and eventually a full ocean. Based on the accelerated rates now being observed, some scientists suggest this flooding could begin in parts of the Afar region within the next million years, practically tomorrow in geological terms. This would make it the first new ocean basin formed on Earth in roughly 50 million years. Impact on local communities. For the millions of people living along the East African Rift System, this geological drama has real consequences. The rifting process generates earthquakes as stress builds up and releases along fault lines. While most are small, the region has experienced damaging quakes, and the accelerated rifting could potentially increase seismic activity. Communities in the region live with both the benefits and risks of this active geology. The rift system provides fertile soils, lakes for fishing, and geothermal energy potential. Ethiopia and Kenya have become leaders in geothermal energy development, harnessing the heat beneath the rifting zone to generate clean electricity. Climate and human evolution. The East African Rift hasn't just shaped the landscape, it has profoundly influenced the climate and evolution of species in the region, including our own. As the rift formed over millions of years, it created a topographical barrier that affected rainfall patterns, gradually transforming lush forests into drier savannas. This environmental change is believed to have played a crucial role in human evolution. The rift valleys also created isolated ecosystems where species evolved in relative isolation, contributing to Africa's remarkable biodiversity. Lake Tanganyika and Lake Malawi are among the oldest and deepest lakes in the world, becoming evolutionary laboratories where hundreds of endemic fish species have evolved. Advanced monitoring technologies. The recognition that Africa is rifting apart faster than expected comes largely from technological advances in Earth observation. Satellite-based techniques can measure ground movement with millimeter-scale precision across vast areas. GPS networks installed across East Africa provide continuous monitoring of crustal movement, while seismic arrays detect even the smallest earthquakes. These technologies have transformed geoscience from a field where scientists primarily studied past events to one where they can monitor active processes in near real time. Particularly exciting is the application of machine learning algorithms to analyze the massive datasets generated by these monitoring networks, potentially providing early warnings for affected communities. The future of the rift. What does the future hold for the East African rift? The acceleration of rifting processes suggests we may see more dramatic events in our lifetimes. While the complete separation of East Africa to form a new continent will still take millions of years, the process is clearly more dynamic than once thought. Some researchers predict increased volcanic activity along the rift system in coming decades. These eruptions could provide further insights into the processes, driving continental breakup while also presenting hazards to growing populations in these regions. Rather than the 50+ million years previously estimated for significant continental separation, some scientists now suggest the process could reach critical phases within 5 to 10 million years. While still beyond human timescales, this represents a dramatic acceleration in our understanding of continental dynamics. What's particularly fascinating is that humans may be around to document this process in unprecedented detail. The rifting of Africa gives us a rare opportunity to witness the forces that have shaped our planet throughout its history, forces that will continue long after our civilization is gone. So what do you think about this incredible geological process happening right beneath our feet? Are you amazed that we're witnessing the birth of a new ocean in real time? Leave your thoughts in the comments below. And don't forget to subscribe for more mind-blowing scientific discoveries about our ever-changing planet.